Afternoon, everyone. My name is AJ Kuftik. I'm happy that you've all joined us today. Today, we're going to talk about our cloud native portfolio. Real quick though, quick housekeeping note. If you have any questions, please enter those down here into the Q&A panel. That helps us keep track of the questions and make sure that those all get answered. Today with us is another one of our principal technologists, Mike Garuccio, to answer all of your cloud native questions. So if you have any sort of questions around cloud native and how all of these things sort of come together, please get those questions in. If you ask a question, you're entered a winner prize. That's right. Another Instant Pot available for you to win. You should make some yogurt. You can make yogurt inside of an Instant Pot. I have not tried that yet, but it's something that's been on my list of things to do, what with quarantine. Hi, Mike. How are you today?
Pretty good. I wanted to let you know you're showing the wrong display.
Am I showing the wrong display? I hit desktop
Yeah,
too.
we got your outline too.
I said desktop 2. It says desktop 1. I don't like that it did that. Are we good now?
Yep, you're good now.
Thanks, Mike.
No problem.
Good to have friends. So if you're asking a question, you're enter a winner prize. This is all being recorded, so you'll get a recording afterwards. This will be available on our website, go.expedient.com/webinar replays, our YouTube channel, youtube.com/expedient, and our Instagram page, Instagram/_expedient. Also, follow us on LinkedIn. You can watch these also on LinkedIn Live. Hello, everyone on LinkedIn Live. You can watch this there as well. For those of you who are new to Expedient, we were founded in 2001. We started in co-location, moved into managed services, and are now in cloud. We have cloud locations US East, Central, and West, so we covered the entire US. And we have international cloud deployments in customer sites in Australia, Germany, and Canada. So if our cloud locations don't work, we can bring that cloud to you. That applies domestically as well. If we're not in an area where you'd like us to be, we can put that cloud there for you. We've been a VMware cloud provider since 2007. We have tens of thousands of virtual machines on our platform supporting over 1,000 customers. So whether you have 2 VMs or 2,000 VMs, we can meet your scale. And we're also a Rancher Platinum partner. And Mike and I have been doing these sorts of conversations with customers for the last year now. And we find that there is a bit of a triangle that involves 3 different sides. The first is our infrastructure team. That's people like me, people who have to build servers and VMs and maintain networks and storage. And by and large, we look at cloud, the overall picture of cloud, as that next level. But it's the security and control that we're missing, right? Cloud is secure, but it's a completely different world for securing things. All of the tool sets, all of the knowledge, all of the skill sets that we have today that exist on-prem are all based on virtual machines. They're all based on physical assets. They're all based on physical networks that we can recognize and know, oh yeah, you put in a firewall here. That's how you maintain the flow of these things. What kind of firewall? Well, this is the type of firewall we've always had. Cisco ASAs, Juniper SRX firewalls, so on and so forth. We know how to operate those, and that is the firewall that we always put into place. When you go out to a cloud, that doesn't necessarily exist. The model changes, that platform changes. Your infrastructure people, though, are always the people who have been the first and the last to answer all of the audit questions. How did this person get access to something? Why did this person get access to something? Who logged all of that? How do we make sure that that person may or may not have access going forward? How often are you reviewing that access? All of those questions are generally answered by your infrastructure or security teams. And that plays against the developer side of the house, because the developers have heard you. They know their apps aren't great. They know their apps could be better. They know, they've seen it, and trust me, they know way more about why they're bad than you do. Like, you're sitting there saying, oh, it's slow, it's clunky, the user interface looks old, but they're looking at the back-end code and saying, buddy, if you could see the band-aids that are back here, because they're holding on for dear life because the business has asked for this function, this bulk import function, this piece, that piece. And it's all been cobbled together to make the application that you use and the business relies on a daily basis. And they want to modernize their apps. They would love to, but they're constantly busy with keeping up with said applications. What they want is the ability to modernize with freedom, because if they go to the infrastructure team and say, hey, we need some new VMs to start landing things on, the infrastructure team is going to ask a lot of questions that the developer team may or may not want to answer, right? They want the ability to go out and utilize a platform so they don't have to worry about middleware. They don't want to worry about the operating system. They don't want to worry about how things are deployed. They want to use an API-based platform as a service. That's why they drive more for hyperscale. And that's okay. But that's where the developer side of the house is coming from. And at the top of this is the business. And the business people don't care about technology stacks. They don't care about controls. They don't care about any of those things as long as those controls are met, as long as the applications are available, as long as the applications do what is needed to make sure that it operates for the business going forward. But the business, especially through this pandemic, has seen a lot of challenges to things like agility and speed to market. This is where a lot of businesses start to struggle when it comes to cloud. They want cloud because they've gone to their conferences. They've been on a number of these sorts of Zoom meetings and WebExes and Teams meetings. And they've heard that cloud is what enabled these other businesses and potentially even peers in their industry to enable them to move faster, save money, make changes, do cooler things than the clunky way that they're currently doing things. So the business is coming back and saying, we want to go to the cloud. That's it. That's the extent of cloud knowledge that they have. We want cloud because we want to go faster. And that's a challenge because the developers and infrastructure teams may have competing visions on what that actually means. So what's in the middle here? How do you actually do this? Well, you have some choices to make, just a few. And I don't know how many of you have good eye vision or, have focus, but there's a lot of choices to make. So many choices to make. This is the Cloud Native Computing Foundation's landscape. You've probably seen this be made fun of on the internet before. I'm making fun of it now. But as we start to look at this, these are all of the pieces that can make up a cloud native infrastructure. Because each one of these boxes, like the scheduling and orchestration one where you see Kubernetes, that's just one infinitesimally small part of the whole picture, right? There's coordination, service discovery, service proxies, API gateways, service mesh, databases, storage, runtimes. All of this forms an infrastructure. And the problem is, and I'm sorry to say this, there's no one right way to go do it. There's no one way to say, well, if I pick all of the big boxes, I'll be okay. Probably, but there's integrations between those things, and not all of them are as well defined as others. There's a lot of challenging ways to do this because I could pick Kubernetes, but I also want gRPC. Maybe I want F5 for my service proxy, and I want to use, I can't even see that, and it's on my screen. So all of these little individual pieces, you could put them all together, but trying to put it all together is going to lead to a lot of time and effort wasted on things just putting a platform together, right? It's like buying a bag of Legos. All of the pieces can go together to make a really cool car. But if you want to make that car, it's got to come as a set, right? Plus, there's the DIY versus platform aspect of this. Even if you do figure out all the pieces to put together and you've made your own very special bespoke cloud native platform, you then have to maintain it. You have to deal with all the interoperability. You have to deal with all the challenges instead of utilizing a platform. This is why a lot of people end up using Amazon's EKS, Azure AKS, or Google GKE, because they are engines that are already pre-built that you can use today. But there's challenges to those as well. How well do they keep up with things? Amazon tends to lag behind on Kubernetes versions. How do they integrate with other pieces? Do they want you to just use all of the platform pieces that exist around that inside of that hyperscale platform, or can they extend out beyond that, right? Google has Anthos, Amazon doesn't really have that. So how do you start to build these applications? Let's say you decide to go down this rabbit hole. How do you start to build your applications? And we start talking about stateless versus stateful. Traditional infrastructure is very stateful, right? I have a server, I have an application, it lives on a server, that server lives on storage, that storage is connected to these VMware hosts, those are connected to this network, and it goes into my DR plan and it goes into my backup schedule. And if something were to happen to that VM or that application, I may need to go into my full DR plan or my full backups to go restore that. And it's going to take a very long time, but my state is always maintained. Cloud native infrastructure is meant to be stateless, right? It's meant to be destroyed and redeployed. But the problem is that data is stateful. You delete data, that's a problem, right? You don't want to do that. So why not both? in the words of the great Professor Zoidberg. Right? Why not both? Why not have a stateless infrastructure with stateful data? And that's how we built our cloud native portfolio. So we have our Portworx storage platform. We have our Rancher environment that actually is a full managed Kubernetes support or a managed Kubernetes platform. But what that allows us to do is connect into things like authentication, which Kubernetes doesn't have, the ability to directly connect and integrate with things like logging with Elastic, which we now offer as a full logging platform. So we have the ability to connect to these best of breed platforms to build a cloud native portfolio and a cloud native platform that you can come in and start consuming today. But that's all a really fun way to say, we have a cloud native platform. Let's actually see this thing, right? Let's take a look at an actual Rancher environment. So we're going to start in here. This is the actual Rancher environment that you would log into. I've already got a cluster pre-deployed. Thanks, Jeff. And Jeff Ely, who's one of our solutions architects in Columbus. Thank you, Jeff. We're going to borrow your cluster for today. But what I have here is this cluster. This is backed by our Expedient Enterprise Cloud. That is our cloud that runs the tens of thousands of virtual machines. So all of these Rancher nodes are virtual. And when you want to deploy a cluster, you're creating cluster nodes that sit on top of Enterprise Cloud. Why is that important? Well, it sits right next to your VMs. So you're on the same networks, you're on the same hosts, so you have super low latency, so you can connect your current applications to your modern ones. So as you're modernizing, there's no weird, well, it's in this, my new stuff is over here in this platform, my current stuff is over here in this platform. You can have all of them sitting right next to each other. So you get a ton of flexibility and a ton of growth capability along with all of that. This cluster is made up of 4 nodes. We have a control node. We have 3 worker nodes. And what I'm going to do is we're going to go back here and we can actually see a number of additional cluster metrics, right? We can open Grafana. This is all built into the platform. So I can see my CPU usage, my memory usage, and get really granular graphs that help me monitor the performance of my platform as I go forward, right? This is something that you would still have to build in. Even if you deployed Kubernetes today, now you have to go add Grafana, now you have to go add Prometheus. All of that is native and baked into the platform. You get that day one, the moment you deploy your nodes. So if we go into this cluster, we can go into storage. And under storage classes, we have Portworx connected to this. And inside of here, we have a number of storage classes. So we have database, DB2. These are storage classes that have a number of different attributes assigned to them that can do things like tell how many things are replicated. So it writes once to each node, or it can write to this node and then replicate that out. You can also do things like a shared replica where it writes to each node at the same time every single time, very similar to the way that VMFS works. And you can have things like a WordPress site where you have a number of different instances all reading from the same storage and all reading from the same data. So no matter which instance your browser hits, you're getting the same data every single time. On the logging side, we have Elasticsearch. And we have a native integration here from our cloud native platform to our Elastic as a service. You'll hear more about that next week. Mike will be back for that too. But we're going to talk through, we have our Elastic logging service that we're able to bring all of these logs in. And this isn't just the container logs themselves, and this isn't just the infrastructure logs. This is all of it together. So all of these logs, as you're spinning up containers, as you're spinning up nodes, watching your environment, all of those logs can filter back into Elasticsearch and you can alert off of those things. So you can see when deployments fail faster. You can see all of those without having to turn on extra logging inside of your containers. You can see it as they're deploying and say, oh, we're missing that dependency. We need to make sure that dependency's in before we actually load that container out. So there's ways to go through and do that. That's all natively integrated. If you have your own syslog server that you want to use, you can connect to that as well. Rancher has a really neat platform has a really neat concept called projects and namespaces. So a Kubernetes namespace is a collection of pods, right? That is actually where the individual containers live. What Rancher does is it adds in this logical layer on top of it called a project, where I can group a number of namespaces together. And that gives me some really neat functionality, specifically around the ability to add access at a very granular level. So if I want to deploy this new namespace, and I want to give Mike access to it, I can add him in as a member, and he now has access to connect into this and manage the containers under here just as much as I do. This is also really great from an operational standpoint because I can add my operations team as members to these namespaces and they can see it, but maybe I don't need them to see my system project, right? They just need to see my individual projects that we have out there. And that also allows you to create things like quotas, so I can make sure that my test resources don't overrun my prod resources. So you can get really granular with quotas and projects and access to make it so that you, as the infrastructure person who has to handle access control and those sorts of things, have the granular level of control that you expect today, while still providing your developers the access they need to get their job done and you're out of their way. So I'm going to go down here into this WordPress project. And I can see that there's no workloads deployed, so that's good. In here, we have a test. We have a test claim for Portworx, and this is actually a 2 gig volume that has the database for a WordPress server. So you can create that as part of your code and deploy that down into your environment, so that when the database writes, it's not writing inside the container, it's writing to this volume that's then shared across all of the nodes, so that when you have a node failure, the other nodes can pick that up and bring that container back online. So now I need to go find my YAML file and load that in. Mike, is there any other things that we could talk about with Rancher and how Portworx and Rancher kind of play together?
Yeah, I can speak a little bit to it. One of the advantages that you kind of touched on, but I wanted to follow up a little bit with, is Portworx really does give you a number of options for data resiliency. So you have a number of replicas across your cluster. So that way, if one node goes down, it's not going to be an issue for your data. Everything's going to be online and available. But we also have the ability to replicate that data to a completely separate Kubernetes cluster in a different location, and replicate the workloads as well. So if you lost an entire data center or an entire cluster, you can very easily fail over. And probably more important on a day-to-day basis, we can take snapshots of those volumes and upload them to a cloud storage service. So that gives you back some of those backup features that we largely lost when moving to Kubernetes. So you don't have to be necessarily application aware in your backups. You can take regular snapshots of your data, store it elsewhere, and if you ever need to roll something back, you can quickly do that.
Thanks, Mike. One of the things we actually have here, this is some code that we had pulled down. This is a WordPress site. I'm just going to be really honest here. We're doing this live. So if you see this website fail, there's some other things we need to do there. But what I have here is this is YAML code that we have to create a Portworx volume. So I can create a persistent volume claim and label it. In fact, I need to change this because the storage classes are different. But when we do these, you can actually create all of this in code, and your developers now have the ability to effectively do infrastructure as code. Right? They can deploy their own volumes, they can deploy their own containers because you've given them access to the correct project and the correct clusters. So it's Portworx shared SC. That's the one we're looking for. Shared SC. Now, this is the very clunky infrastructure-based way of doing it. If you were going to do this the correct way, you would go in and connect your Visual Studio Code or your code developer of your code deployment environment of choice. You would connect this to the Rancher API or even kubectl and run these commands directly through a pipeline. So as you're doing your deployments, you would go that way. Because I am a clunky infrastructure person, I'm not doing that. But what I can do is I can read from a file. And we'll do WordPress vol, and we'll import. And if I go to my volumes, I now see that I have this WP PV claim. So I've created a 1 gig volume on the Portworx environment itself through code. Didn't have to click anything. I can go create it all myself. And then there we go. That's a lot easier. I can go deploy my MySQL volume as well. We want to make sure that those are want to make sure that we have all of that as well. And if you have any questions, please feel free to get those in. Again, we have a great instant pot prize. So we can do that as well. Cluster there, I clicked out of it, that's on me. Project, import YAML, there we go. Read from file, volume. So again, dropping in a MySQL volume as well. So I now have these bound persistent volumes. So every time I deploy my containers or I delete my containers and redeploy them, I'm able to access them. So we will go to MySQL because we need our database before our application. Import. And so now when I go to my workloads, I can see that I've deployed this container and it's creating the pod and it's doing the actual deployment of MySQL into it. It's pulling from an image source. So I'm able to land all of this in there. Secret MySQL path not found. I see it. It needs the text file. The input's wrong because it's pulling in just the YAML file because it can't see the password file. See, this is troubleshooting. But when we actually deploy this through the code pipeline, which is how the original demo went, when we deploy this through the pipeline, it pulls in from a text file. So I'm not storing my passwords inside of my code. That's a bad thing to do. But once it lands that in there, we can do that. Let's see if I can. We'll do this. Shh, don't tell anybody. Don't tell anybody. Delete, import, read. Because it's trying to pull it. Because it's secret key reference, because they're trying to have me do it the right way. With that, we will move on with the demo. The demo gods did not shine upon me today. We'll get them next time. But that is our Expedient Cloud Native platform. With our Rancher platform, we can do authentication, container management, and our image repository. So we can have all of these things baked in and native to the platform. You don't have to configure them. We can connect, we can integrate with your Active Directory, your Azure AD through a platform called One Login. So that allows us to do all of the authentication things that you need to do without having to manage different authentication points. With Portworx, we can do persistent storage. So I can do all of my writes, delete things, bring them back. As we do a redeploy, the Portworx volume stays there. It's persistent, so your data is stored correctly. With Elasticsearch, we have we can do all of the log monitoring that we need. We can import all of those logs in. We can bring up dashboards. You can have all of the very nice images so that your operations people can see things as they come in, but still have the ability to go in and dive deep into your logs to find problems. And then our enterprise cloud, you land your VMs next to your containers, next to your cloud native applications, and that can help you migrate forward. So you take all of the work off of your existing workloads, your VM-based workloads. You don't have to worry about patching or management with those, and you can focus on your cloud native and modern applications going forward. So what's actually in the middle here? The infrastructure team, they maintain their platform knowledge, but they gain those audit controls. The developers get an API front end, they get all the scalability, they get the containers, the modernization platform that they want to have, and then the business is able to move faster than the market. I'm able to take all of this and put it all together, have the Expedient powered cloud native platform that is able to modernize your applications. So your cloud journey can start with things like colocation, physical hardware, legacy apps. We can set those right next to our enterprise cloud, those tens of thousands of virtual machines and over 1,000 customers. We can maintain your virtual machines, eliminate all that patching, eliminate all the headaches of maintenance and management, so that you can focus on your cloud native apps going forward. So you can do this with your containers, with your next generation code, so your developers can help get you there faster. And not only that, but this Rancher platform, one of the really neat things about it is that it can connect to Amazon AKS, to Azure, Amazon EKS, Azure AKS. I really don't like that they switched those around, and GKE. So you can manage your cloud native applications no matter what cloud they're on. That applies to our Elastic platform as well. If you want to bring in logs, bring in monitoring, we can pull all of those in together. So it's actually some of the things that you'll be hearing a lot more about coming soon. Mike, did we have any questions? We have one. We have one question here. Two. First question here, how do you utilize these tools and methodologies when your stack development team management require full VMs rather than containers and services?
I guess the short answer there is kind of that you don't. If you absolutely need full VMs, you're kind of stuck in that world of deploying the full virtual machines, whether that be on Expedient's infrastructure or on a hyperscale cloud. As AJ is showing right now, you can do some of the API deployments and use some configuration management tools like Ansible, that sort of thing in order to deploy VMs. You won't be able to take advantage of a lot of the unique things that Kubernetes brings, though. So that's going to be your auto healing, some of the auto scaling functionality, extremely quick deploys. I would, however, query your dev team on why exactly they need those full VMs. Some workloads absolutely do belong on traditional VMs, not containers. But as a blanket policy, I would suspect that that's more a matter of needing some additional education and some additional advocacy internally to really determine what the best fit for the applications is, rather than going with just what you've done before.
And I think the other piece there is that's why I brought up the API documentation. We have the ability to connect to Terraform and Ansible. So if they do want to do full VM deployments, we can still do that, right? This is not a cloud native, doesn't replace our enterprise cloud. Cloud native is a complement. It sits on top of our enterprise cloud. So we're able to do both. If your developers are only in sort of one area, they're still very focused on our one way of doing things, that's okay. You can bring them along, and then once they see the power of a cloud native platform, they can start to say, oh, hey, this is actually a nicer way for us to do things. We can actually move things a little faster. That's where we want to go. Second question here. Well, this is the first time I've heard of Rancher. How long has this company been around? Rancher's been around since 2015. They started earlier than that, and then they pivoted into this. But Rancher is one of the industry best of breeds when it comes to managed Kubernetes. You've probably heard of Red Hat OpenShift, VMware Tanzu. Rancher was doing managed Kubernetes before those. They've been in the game for a very long time. We have a deep partnership with them. We thank them for their partnership. And it allows us to do a lot of things. They're just a much more mature platform. They've already figured out a lot of these things. They're not trying to, nail down what's happening or try to integrate into an existing platform. They're trying to be as agnostic as possible and let integration partners like Expedient connect things like Rancher to our VMware Cloud Director platform. That's actually a big driver for us. But Mike, you may have some deeper facts on that.
No, you pretty much covered it. I just wanted to do a quick look up. So they were founded in 2014. They were originally a container orchestration vendor, so they were competing with Kubernetes, but eventually, just like the rest of the market, adopted Kubernetes and added their layers on top. And in terms of making sure that they're a stable company with a stable path forward, they were acquired by SUSE last year, so they have plenty of institutional backing by one of the leaders in the Linux space.
In terms of authentication capabilities that you mentioned, do we offer a white label solution, permit third-party authentication, or both? Both. We have managed Active Directory, so if you want to do that, we can do that. We also have one login, which can integrate with SAML to Azure AD, basically the same sort of realm as, like, it's a single sign-on product, right? So whatever your authentication provider may be, we can integrate to that. That's actually something that's the big reason why we deployed one login, is to help all of our products, not just Rancher. We have one login for this, and also our enterprise cloud and our networking tools and additional services that we're offering, to bring together a literal identity platform, so that it doesn't really matter where the authentication source is. It feeds through one login, and that provides a nice authentication layer for our overall environment.
One thing I would add on authentication that kind of makes Rancher unique is that it's the only platform that you can authenticate to with your 2FA and then download a kube config file that you use just like you would if you just spun up a cluster with kubeadm or something like that. You don't need to re-authenticate every time, and it will actually proxy the traffic to your cluster. So as long as you can reach the Rancher front end, you can control your cluster and don't have to expose it out to the internet to get management.
Are all of the components of what was shown today packaged together? Or are there additional services that we offer that integrate easily into the Kubernetes as a service platform? So these are all services that integrate together. They are separate services, but as we do everything at Expedient, we help build solutions. We don't just come in and say, here's the product, off you go. It's not, here's 15 services and it's up to you to go figure those sorts of things out. We sit down to build the right solution for you with the right services together, so that you're able to do and meet the needs of your business and get that outcome that you're looking for. So we have those where we have monitoring things that are coming that will also integrate into this platform. We have other pieces that, again, there's a lot of stuff coming in our roadmap. Our roadmap is hot. But as we have a lot of these sorts of things coming, they all play together with the cloud native platform. It was a big piece that we made sure was not just a one-off sort of thing. We built it as a platform to be scalable for our customers' needs. Mike, do you have anything in particular that would integrate there?
Now beyond what we've shown today now.
Okay. Last question here, and this is a wildly loaded question that is probably its own hour-long discussion. So we should reach out to you about this. What would the migration path be to move an app from .NET Web Server or MS SQL Server to cloud native?
Well, so step one there is moving from your current .NET platform over to .NET Core, which will run correctly on Linux, is supported in containers. Technically, Windows containers are a thing, but they're still early and there's still a lot of caveats there. So you're much better off re-platforming yourself on the .NET Core. That opens you up to running Linux, Windows, or containerized, so you get a lot more freedom. Once that's done, you'd work on getting things running correctly in containers, so just using Docker. Once you're happy with that, then you'd look to move them into Kubernetes. To be honest with you, the database probably one of those workloads that probably belongs in a VM and may not actually belong internal to the cluster for MySQL, but that is something we should probably dig in deeper for, and we can reach out to you.
But what's actually interesting is that because this sits on top of our enterprise cloud, you can keep that MS SQL Server as a VM on that platform and have direct sub-millisecond latency to your containers that you would be migrating your .NET Web Server over to. So there's a number of different capabilities that we have here. It's not just you're in a VM now you need to be all cloud native. You can do a mix and a hybrid of both to get the thing that you actually need. I think that's actually a really cool thing that we can do. Quick upcoming events. Thursday, we're going to do, in fact, we'll talk a lot more about these sorts of concepts with migrating and modernizing. We're going to talk about, what do you do with your workloads? Do you just pick them up and move them? Or do you really go under the hood and try to make them as optimized as they can for the platform that you want to get to? And then join us again next week. We're going to talk about Elastic as a service, where we're going to go through all of the ins and outs of Elastic, how logging works, how we can actually utilize an Elastic platform to help you see deeper into your environment and get better observability. And if you want to get your hands on this Rancher platform, please reach out to me, aj.kuftik@expedient.com, or go to expedient.com/vmware-test-drive, and you can sign up for a free 30-day trial. You get 128 gigs of RAM, a terabyte of storage, so you can try out the hybrid SQL Server container world that we're kind of putting out here. And also we can sit down and talk with you about some of your more cloud native aspirations. the winner of the Instant Pot, before we go, is Harry Scandalarius. So congratulations to Harry. You are the winner. Karen will be reaching out to you. Again, if you have any additional questions that you didn't get answered, maybe you think about later, please, again, reach out to me, aj.koptic@expedient.com. I want to thank Mike for joining us. He'll be back next week too. So we'll be answering all of these sorts of similar questions. And we hope you have a great rest of your day, and we hope to see you Thursday. Thanks.